In this video, we'll learn how to divide a polynomial function, say f of x, by a linear function looking like ax plus b. To do this, we'll work through two examples in which we'll be using the nested scheme, or Horner's method. So let's get started. Let's consider this first example. We need to divide the polynomial f of x, which equals to 6x cubed minus 5x squared plus 6x plus 13 by 2x plus 1. Now, the way we do this is we start by solving the equation 2x plus 1 equals to 0. And it doesn't take us long before seeing that the solution to this is x equals to negative 1/2. We now use the nested scheme to evaluate this polynomial function f of x at x equals to negative 1/2. And we do this here. We make our table, and picking up on the coefficients of this polynomial, those are 6, negative 5, 6, and 13. And we're evaluating this at negative 1/2. So, carrying down the 6, negative 1/2 times 6 is negative 3. Negative 5 plus negative 3 is negative 8. Negative 1/2 times negative 8 leads us to 4. 6 plus 4 is 10. Negative 1/2 times 10 is negative 5. And 13 plus negative 5 leads us to 8. And so these numbers at the bottom are our coefficients. We have 6, negative 8, and 10. That will be for our quotient polynomial. And we have our remainder, 8. Now, an important thing to realize here is that this quotient function, which will be a quadratic, is in fact the quotient function upon division by x plus 1/2. But we're looking for the quotient function upon division by 2x plus 1. And we'll see how this is done right now. So far we can write f of x equals to x plus 1/2 times this quotient function. So that's 6x squared minus 8x plus 10 plus 8. And for us to change our x plus 1/2 to 2x plus 1, we need a factor of 2, and we'll take that 2 outside of the second parentheses. We do it like so. That's x plus 1/2 times 2 times 3x squared minus 4x plus 5, plus our remainder 8. Now, distributing this 2 across the first parentheses leads us to 2x plus 1, which is what we were after, times this new quotient function, 3x squared minus 4x plus 5 plus 8. And this is what we're after. All we need to do now is divide both sides of this by 2x plus 1 to write down the final answer. F of x divided by 2x plus 1 equals to 3x squared minus 4x plus 5 plus 8 over 2x plus 1. And there we go. Let's look at one more example. Let's say we're given the function f of x equal to 5x to the power of 4 minus 17x cubed plus 6x squared plus 5x minus 4. And we wish to divide this by 5x minus 2. Well, once again, we start by solving the equation 5x minus 2 equals to 0. And this quickly leads us to the solution x equals to 2/5. We now use the nested scheme for this polynomial function at 2/5. So that would look like follows. The coefficients here are 5, -17, 6, 5, and -4. And we're evaluating at 2/5. So we carry down the 5. And now 2/5 times 5 is 2. -17 plus 2 is -15. 2/5 times -15 is -6. 6 plus -6 is 0. 2/5 times 0 is 0. 5 plus 0 is 5. And 2/5 times 5 is 2. Finally, -4 plus 2 is -2. And so we now have a quotient polynomial, q of x, as well as the remainder, r. And once again, we need to be very careful and realize that here we have just found the quotient polynomial for division by x minus 2/5. But we're looking for the quotient when we divide by 5x minus 2. So we'll see how this is done right away. We can write f of x equals to x minus 2/5 times the cubic 5x to the power of 3 minus 15x squared plus 5 minus 2. And now we're going to need to take out a factor of 5, and we take that factor out of the second parentheses. And that looks like x minus 2/5 times 5 times x cubed minus 3x squared plus 1 minus 2. Distributing that 5 across the first parentheses, we find 5x minus 2 times x cubed minus 3x squared plus 1 minus 2. And that's exactly what we're after. Now all we need to do is to divide both sides by 5x minus 2 to write the final answer. F of x divided by 5x minus 2 equals to x cubed minus 3x squared plus 1 minus 2 over 5x minus 2. And there we go. That's how we do synthetic division with polynomials.